All right, today we're going to talk about division, which is really also another way of talking about fractions with radicals. So here's an example. This is very similar to when we had square roots. If we had the square root of a over b, we said we could also break that up as the square root of a over the square root of b. And the same thing will be true for any other root, cube root, fourth root, so forth. So let's look at an example. Here's a square root of 10 over the square root of 15. So if you remember when we talked about this previously, it's always a good idea to think about this as one radical, the square root of 10 over 15, since the indices are the same. And you should simplify that fraction, 10 over 15. So you can simplify that to the square root of 2 over 3. But now, of course, you cannot leave a radical in the denominator, so you have to rationalize this by multiplying by the square root of 3 over the square root of 3. And your final answer will be the square root of 6 all over 3. All right, that's great. That's what we did with square roots. Let's now apply that to a different root. Let's take a look at a cube root. So here I have the cube root of 6 over the cube root of 12. Again, I can think about this as under just one radical and simplify that 6 over 12 to 1/2. Now, when you're rationalizing that denominator, you have to think in terms of perfect cubes. So I cannot just multiply by the square root of 2, because that would give me the cube root of 4 in the denominator, and the cube root of 4 is not a perfect cube. So you want that denominator to be an 8, because the cube root of 8 is 2. So in order to make the denominator 8, you have to multiply by the cube root of 4 over the cube root of 4. That'll give you the cube root of 4 over 8, and then you just simplify that cube root of 8 to 2. All right, here are some examples. Why don't you put the video on pause and see if you can do these yourself. All right, the first one, did you get that answer correct? All right, so the first thing you could look at is the cube root of 8 in the numerator can be simplified to 2. So I think I would do that. And then in the denominator, I want that denominator to be a 27. So I have to multiply by the cube root of 3 over the cube root of 3, which will then give me the 2 cube root of 3 over the cube root of 27, which of course is 3. In the next one, I can't do anything with 3 over 4. That cannot be simplified. So what I'm going to do is just multiply by the fourth root of 4, because I want that denominator to be 16. That'll give me the fourth root of 12 over 16, which I can simplify the denominator. Now this next one's a little bit different, because now you're thinking in terms of exponents. So again, there's nothing I can simplify on this one, but I want this denominator to be a perfect cube. If you remember when we talked the other day, y to the third would be a perfect cube. So I have to multiply the numerator and the denominator by the cube root of y squared. When I do that in the numerator, I'll have the cube root of x squared y squared, and then in the denominator the y cubed, which is what I wanted, and then I can simplify that denominator. Forget that, that's not supposed to be there, but we'll continue. All right, so let's take a look at this example. So I have 28a cubed b squared over 4a to the 6th b to the 4th. The first thing I would do, as always, is look inside that radical and go ahead and simplify what's in there. So 28 over 4 can be 7. A to the third over a to the 6th can be a to the third in the denominator, and b squared in the denominator. So once I've done that, now I can start to think about rationalizing. Well, I want that a cubed to be an a to the 5th, and I want the b squared to be an b to the 5th. So I have to multiply by a squared b to the 3rd. I do that, and then I can go ahead and rationalize that denominator. Let's look at the next one. So once again, even though these are two separate radicals, I can think of it as being under one radical, and I can go ahead and simplify this. So 15 over 25 is going to give me 3/5. A to the 4th over a to the 5th will give me a in the denominator, and b to the 6th over b to the 3rd will give me b to the 3rd in the numerator. I want to rationalize my denominator, so I'm going to multiply by 25a squared, which will give me this, and then I can rationalize that denominator. But then you noticed here, I have b to the 3rd, which I can simplify. I can take that out of the radical as just b. So make sure that you look for that as well. If you can simplify something by taking it out of the radical, you would need to do that. Now this is an interesting example. Here I have a square root in the numerator and a square root in the denominator. But look at the denominator. It is just one square root in the denominator. So in order to get rid of that or to rationalize that, I'm going to multiply it by the square root of x plus 2. That'll give me the square root of x plus 3x plus 6 over x plus 2. Pretty straightforward. But this one here is different because now in the denominator I have only one square root, but it also has a plus 1 in there. So I can't just multiply it by 1 plus the square root of 2 because I would not be getting rid of my radical if I did that. So you're going to have to multiply it by its conjugate, just like we did with imaginary numbers. This will give you in the numerator 3 minus 3 square root of 2, and then the denominator will just become 1 minus 2. And you can simplify that. Remember, you're not going to keep a negative in the denominator. All right, why don't you try these and see if you can get the answers to these. All right, did you get the first one? Once again, I have a radical in the denominator, but I also have plus or minus a number, so I'm going to have to multiply by its conjugate. And then just simplify that denominator. Now this one here, I have two radicals in the denominator, but again, they are separated by a plus sign. This is not the same thing as x plus 3. So don't think of it that way because this is very different. So these are not the same thing. So I'm going to have to multiply by its conjugate, just like I did in the first example. When you do that, you'll get this for your answer.